In today's lecture, I will describe how to develop an ARIMA model. In order to better understand this lecture, I recommend you to please watch my previous video on theory on ARIMA models. So first of all, this is my Jupyter notebook. I'm using Python language. So we will import general libraries, NumPy and Pandas, and Matplotlib for graphs. This is for making graph inline, and this is by this code we set the figure size because we don't want big figures. Now, by using Pandas library, I will import the CSV file which contain data on time series. I have taken the resources in this lecture from various websites and tutorials. So let me run this code. Then importing the data. This is how the data is there. These are the number of passengers in various months, and the column month or field month is set as the index column by this code. Now let us plot the time series. This is our time series. So the number of passengers, they are progressively increasing. So there is an increasing trend. Moreover, there is seasonal variation. So in this our time series, we have a trend and seasonal variation. Let us see the rolling statistics. So this is the rolling mean, which is increasing, and this is the rolling standard deviation, which is also increasing. So our time series, in fact, is a non-stationary time series. It have a trend and a seasonal component. So let us do Decupicular test. So Decupicular test p-value is more than 0.05. It is non-significant because our time series is not stationary. Then let us plot the ACF and PACF graphs of our original series. These are the ACF and PACF data. Now the graphs are, these are the graphs. So this is autocorrelation. So it is showing a gradual decrease and a seasonal component. So this gradual decrease means there is a trend. I have explained this in my lecture on theory on ARIMA model. Then in partial autocorrelation, this we have two spikes significant. Then let us do some transformation of our time series so that it become more or less stationary. We can first take a log of time series and then do the difference, or we can do a difference directly, or we can do difference two times. For this, I have done the difference one time. So let us do the difference. So this is the time series after differencing, and this is the result of Decupicular test. So Decupicular test p-value is almost significant. It is near to 0.05. We can do, in fact, two-time differences, but this is almost significant, so we can continue with single difference. This is again Decupicular test of the different series, then the ACF and PACF values. These are the values. Then let us see the graphs after differencing. These are the graphs after differencing. So here, this is the ACF graph and this is the PACF graph. In this PACF graph, there is a gradual exponential decrease, and in autocorrelation graph, there is a single peak which is significant. So, uh, as I described in my previous lecture on theory on ARIMA model, we need to use a moving average with parameter of 1 in this case, because partial autocorrelation, there is exponential decrease, and in autocorrelation, there is single peak. And these peak, they correlate with the seasonal component. So let us build our model with the order of time series as parameter 0 for autoregression and parameter 1 for moving average, and this is for seasonal component. So let us develop our model. So our model, this is our model, and this is the uh, fitted values in red color, and the blue color is original model. Now let us predict for next few years. The blue color up till here is the original time series, and the orange one is the predicted values, and this is further for few years. Now this is about how to develop an ARIMA model. There is another useful package known as PMD ARIMA, and this can be used to identify the parameters for ARIMA model automatically. So let us see how it works. This is for installation of this package. I have already installed in this computer. So let us run this one. And then auto ARIMA. So this is our auto ARIMA. It is working now. So it says that best model is with the parameter 0, 1, 1, and this is the seasonal component with the interval of 12 months. Now let us see summary of our this ARIMA model. So let us see the summary. So this is a summary of our best model identified by Auto ARIMA. This is a summary. This is the model, and this is the log likelihood, AIC, BIC values. So I hope this will be very useful for my audience. This is all for today. Thank you very much.